Hey everybody, welcome to today's Getting Started with Kubernetes on Rancher 2.0 session. Really excited for our training today. We have quite a few people joining the training right now, and we are just getting started. So just to quickly go over our objectives today, we're going to go ahead and dive right in here. We are going to start with what is the goal. I mean, we want really to give you guys, a solid technical introduction to Kubernetes using Rancher. We're going to start off with slides, but we'll get into the demo very quickly and just demo. As usual with these trainings, there will be a lot of questions. Please ask your questions. GoToWebinar has a pretty awesome question and chat feature. So, start putting your questions there and we will answer to the best of our ability and do our best also to leave no question unanswered. Again, though, this is an intro training, so try to keep to that level, and if we are unable to answer it, we might direct you to another resource outside of the training. So who's on the call today? My name is Matthew Shear. I'm the community advocate with Rancher, and doing our demo and really the technical expert on the line is Jan Bruder in Germany. Thanks for being on the line, Jan. Good to have you.
Hi, everyone.
Hey. And Jan let me know he has a little bit of allergy, so hopefully he won't be easy to understand, and we'll be able to answer all your questions and do a great demo today. And again, our Twitter handles are here. If there's additional questions you guys have, if you want to participate, I mean, our stuff is open source, and so if there's a way that you want to plug in, please continue the conversation. You can reach out to us through Twitter or through email, or just get in touch and we'll be there. So just a little bit of context for today's training. It is mainly focused on Kubernetes and Rancher. We kind of assume you have some Docker under your belt, some basic container understanding under your belt. There's a lot of resources online, on our blog, in our docs, and if there's something that you don't understand, you can always use those resources as well. This is a link to our quick start guide to get up and going with Rancher. I'm not sure where Jan will start off in his demo, but we might start from scratch or already have an instance running. Either way, this is where you would go to get started. And this slide, like the other slides, will be available after the session. We're going to send out an email with a recording of this session and all of these slides as well. So don't worry about trying to get that URL down right now. You'll get it after the session. One other thing, the forums and our Slack channel are a great place to have continued community around these topics. They're challenging for everybody, and we're all learning as we go. So please use our forums. Our engineering team goes there and answers questions and gets a poll on things too. So it's a great resource. And at this point, I'm going to go ahead and pass it over to Jan. We'll get some context about Kubernetes and why we're talking about what we're talking today. And then we'll get started with the demo. All right. Jan, are you ready to?
Sure. Yeah, I'm ready. Let me see which button I have to press.
Yeah, totally. All right, I'll send it to you.
All right. Do you see my screen now?
Yeah, I can see it. Okay,
so starting off, I just want to talk a little bit about where we are going with Rancher 2. Often we have, I suspect even today, we have probably a lot of users of Rancher 1. So the question is often raised, where we're going with Kubernetes in 2.0. As you know, we have been supporting Kubernetes as an orchestrator to run your workloads in Rancher since pretty much the beginning, among other orchestrators. So now in 2.0, we are focusing completely on Kubernetes. And I just want to talk quickly with you about what are some of the reasons for that. So first of all, in the past year or so, we have seen that the interest in the industry in Kubernetes has grown substantially, and that is especially because people are appreciating the scalability and the design patterns of Kubernetes. And we have seen a number of large software companies that have publicized their use of Kubernetes in production. And actually now we see more and more IT vendors as well to add managed Kubernetes offerings. So if we look at the code base of Kubernetes, we can see that a lot of the big players are basically contributing to the Kubernetes code base, which is a good sign. So let's move forward. Yeah, so as I said, we have been supporting Kubernetes for quite a bit of time, and we had a lot of feedback from users, both Rancher users, but also just users trying to deploy Kubernetes. And so we learned about some of the challenges that they were facing, and just going through the list. So one of it is if you want to deploy, scale out, deploy multiple Kubernetes clusters, especially in different environments, how do you ensure that your deployments are consistent across these different infrastructures? There are a number of tools to deploy Kubernetes. Some of them are scoped for specific environments like AWS or in a private cloud. So if you have like a hybrid approach and have multiple environments where you want to deploy Kubernetes, that can pose a challenge with regards to consistency. Also, the question of integrating something like your local user directory, like your enterprise Active Directory, with the Kubernetes cluster, and basically leveraging the database to manage access control in your clusters. That's also a big question. Another question a lot of people had was, how do I partition my clusters so that I can more efficiently use my resources? What does it mean? Well, let's say you have a cluster and you want to share it across different teams. In Rancher 1.0, for those people that are familiar with Rancher 1.0, we had this idea of environments, which were basically a collection of a specific set of nodes and access control configuration. And you couldn't really share the same set of nodes with different teams while still having isolation between them. So this is something that we are addressing here. And basically, Kubernetes has the concept of namespacing, but it's a little bit hard to manage that in production, especially with multiple clusters. So we're going to come to that further on. And yeah, then once I have a cluster, maybe for a little POC or something, how do I actually then make it high available so that I can deploy it in production? And also, how do I manage security policies and pod security policies and network policies across all clusters? And then finally, once I have my cluster set up, how do I ensure that I have visibility into what's going on and being able to troubleshoot any issues with my monitoring? One other operational challenge is that the Kubernetes development itself is moving at a very fast pace. So Kubernetes is actually one of the top 5 of all GitHub projects with regards to the number of developers contributing code. And there are more pull requests and issue commands than in any other project in GitHub. So that means in practice that you get a new Kubernetes release approximately every 3 months. There's no long-term support version of Kubernetes. So what that means in in practice is that you will spend a lot of time of qualifying new releases and rolling out updates basically every few months. And yeah, so another challenge is, apart from the operation, is the usability. So when people start to learn about how to interact with Kubernetes, how to deploy workloads and such, they realized pretty soon that the learning curve is pretty steep, especially if compared to something like Docker. A lot of people are familiar with Docker Compose, stuff like that, but you can't really leverage that knowledge when you want to write Kubernetes configuration files. So that's also something that we are addressing in Rancher 2. Yeah, so basically what you get with Rancher is easy-to-use interface for your deployment of Kubernetes and for your configuration. You get infrastructure management across multiple clusters of cloud. So we really, as in OneDot, we want to be pretty much agnostic to the infrastructure that you might want to use. So we want to make sure that it works on bare metal, private cloud, public cloud, what have you. Yeah, then we also manage RBAC security policies and allow you to manage your workload in something that we call projects. I'm going to talk about that also in a minute. Yeah, so if you look at this picture, basically what you see on the bottom is the basically the deployment target or the environment that we support in Rancher for your clusters. So you can see that we have all the private clouds there, VMware, vSphere, OpenStack, and the public clouds. In addition to that, we also support actually the managed Kubernetes offerings from Google, Azure, and Amazon. And yeah, let's go on. So if you're interested on the architecture, so especially if you're coming from Rancher 1.0, this has changed quite a bit. So in Rancher 1.0, we are basically using a MySQL backend as our data store. And all the Rancher components were running as containers managed by the Docker engine, basically on the hosts. The big difference in the architecture now is that the Rancher components themselves are running in a small Kubernetes cluster. And we also dropped the MySQL database, and instead we are using etcd, or rather we are using the Kubernetes API as our own data store for our components. And so what you see on the top, that is basically your management cluster in the square box. This is what you deploy in order to get started with Rancher. And then on the bottom are all the clusters that you either import into Rancher or create out of Rancher. Yeah, starting off, just doing a very short crash course with Kubernetes if you've never dealt with it. As I said before, if you're coming from Docker, Docker is basically, I mean, as far as Docker semantics are concerned, there's basically just the container, there's the volume, and maybe there's the network. With Kubernetes, you have a lot more semantics that you need to learn about. And let's just go quickly through some of the most important ones. So starting off the pod, that's basically the atomic unit in Kubernetes. That's basically the smallest unit that you're ever going to deal with. What a pod is basically a collection of one or more containers that are bound together. So they're always scheduled together on the same host, and they live and die together. And the other thing that is special with pods is that they share a network and I think network namespace. So that means they can talk to each other on localhost. But of course, also they can have conflicting listening ports in the applications. So I would say in 80% of the times, a pod will only consist of a single container, but there are actually some nice patterns that you can do with these pods. For example, having your main application in a pod and then have a sidekick container that just provides some bootstrapping for the application, like injecting configuration and stuff like that. So that's the pod. As I said before, that's the smallest atomic unit in Kubernetes that you're dealing with. And most of the time, you're actually not dealing with pods because you're going to interact with a abstraction layer above it, which is either a replication controller or a replica set. basically this is what this is what describes the desired state of the pods. So which all the properties of the containers, which image it uses, environment variables that you want to inject and stuff like that. What is the scale? So you can basically write a replication controller and give it to the Kubernetes API, and then Kubernetes has the controller manager, which basically takes this replica set and then tries to drive the state in the actual cluster towards that set. So it starts pods, make sure that the pods are running at the set scale and stuff like that. And then next off, we have deployments. They are another level of abstraction above replica sets. They basically, what they basically do is just they create and update the replica sets. So why should you use deployments? Well, they make it really easy doing stuff like performing rolling upgrades and scaling. So that's deployments. Then we have a service. Service is basically defines the networking for your applications. So there are different types of services. The basic type is a cluster IP. What that is basically an internal endpoint, like an internal load balancer that forwards traffic. Basically, you talk to the cluster IP and then it forwards traffic to the actual pods. So normally, if you have like an application that consists of multiple services and they need to talk to each other, they usually do it by using the cluster IP, because the cluster IP makes sure that the request gets forwarded to a pod that is actually running and can handle the request. Another type of service is the node port, and basically a node port is a mapping on the host network interface. And one interesting thing, or maybe different thing in Kubernetes, is that other than maybe Docker, if you map a pod to the host, it will actually be exposed on all the nodes in the cluster. So what that means is you don't have to go to a specific node in the cluster. You can go to any node in the cluster, hit the port, and then the traffic will be forwarded to one of the pods. And another type service type is load balancer. Load balancer basically works if you are in an environment that has an infrastructure load balancer, like on AWS, Elastic Load Balancer. And what this does, it uses that external load balancer to ingress traffic into the cluster. Basically, the way this is done is basically by dynamically provision, like an Elastic Load Balancer, for example, in AWS, and configuring it to forward the traffic to the pods. Then you also have config maps. So if you come from like just Docker containers, where you would usually use environment variables in the Docker Compose file to configure your application, basically what the config maps gives you is that they decouple the storage of the configuration from the configuration of the pod of your container. And then once you start the container, the configuration is then injected into the container. And another semantic is also the so-called ingress. That's basically another way how to get traffic from outside routed into the cluster. An ingress can be something like a reverse proxy running in the actual cluster, but it can also be an external load balancer, or like an F7, for example, or it can even be a router, basically anything that knows how to get traffic into the cluster. Yeah, so this was it for our crash course.
Hey Jan, really quickly, a question from the audience. Hui Yin asks, "What is SOT?"
Oh, okay. Sorry, what was that? Probably here. It's just an abbreviation for source of truth. Basically, the replication controller is a source of truth for all the pods that are created by the controller manager. Yep.
Cool. All right. Thank you.
Yeah. Okay. So now let's get started with Rancher 2.0. So set up Rancher, create a cluster, and then talk about all the stuff that you get with Rancher. If you just want to follow along, that's fine. If you want to actually try it out during the session, you can do that as well. I think you will be fine if you just have 2 virtual machines ready with Linux, like Ubuntu running on and a supported Docker version. You could actually follow along because it's not really hard what we are going to do. So let me just switch out of this window. We have a quick start guide in our documentation. If you go to rancher.com docs, and for this first part, we just gonna follow along here. So these are the system requirements for running the Rancher management plane, which we have to do before creating any additional clusters. And as I said before, Rancher is running in a Kubernetes clusters. And with this, for the purpose of this demo or for any kind of sandboxing, you can actually use our Docker container, which runs a small Kubernetes cluster in a single container. So we don't have to create a cluster before that. And once you have a VM ready with a supported operating system, around 4 gig of memory, and one of these Docker versions, 112.6, 131, 1703, there's basically just one command that you need to do. So just start our Rancher container, and we're going to export port 8080 and port 443 for the user interface and for the API. So let's see. Yeah, so that's the command that you get in the quick start guide. This is going to pull the Rancher image, and yeah, once the container is started, basically we will create a small Kubernetes cluster in it, install all the Rancher components, run the etcd data store, and then after a minute or so, you should be able to access the user interface on the IP of your virtual machine. So I think I have one running here. Yeah. All right. So I just did that a bit before. Let's get our IP address. I think I might have actually. Oh, I already have it here. So once you access your the user interface for the first time, it will prompt you to set a password. So by default, the deployment is password protected, and it will also ask you for the host registration URL, which most of the times should match whatever you put in the browser to reach that server. So a domain name or an IP address in my case. Yeah. So this is basically the screen you get once you have deployed the Rancher container. And let's just see what we can do from here. So as I said before, the first thing, you're setting an admin password, and then depending on which environment you are, so basically this uses local auth, right? But if you want to use a user directory in your environment, like Active Directory, or you want to leverage GitHub auth, you can set this up here, right? So that's similar to what you had in Rancher 1.0 as well. And the next thing you want to do is configure some of these global configuration things. So one of that is the pod security policies. Basically, there's a Kubernetes term. Basically, what the pod security policies do is they let you define the security boundaries for running pods in your cluster. Basically, what capabilities can pods gain? Can they mount volumes on the local host, and all these sorts of things. So if you go to add policy, you can add a test policy, and then you can say what kind of volumes they can use, These are all like the kernel capabilities that you want to allow basically pods to be deployed with. So this is all security related stuff. And yeah, and the cool thing is you have, again, a single source of truth for all clusters. So you just define all this stuff once in the global level, and then when you create a cluster, you can refer to that configuration. And another important thing is the roles. So Kubernetes has a very, very advanced role-based access control system, basically where we have a very fine-grained control over the CRUD privileges of users, and we have some default roles defined already, and they're also different depending on the layer on which you're working. So if you're in a cluster, you would have different roles for users or than users on the global level. So if you could just add a new role. And the nice thing is you can inherit from a role, so they are all additive. So you can just add an existing role and then maybe extend it with additional grants. So you can see from this list that, yeah, these are basically all resources in the Kubernetes API. And for every single resource, you can set the access control. Yeah, so these are the things that you at the global level. If you go to settings, you can set up your own SSL certificates. You can also override the default registry. So this is important if you are in an air-gapped environment where you cannot access the Docker Hub, the public registry. And then in users, you can start create a user. Let's just call this test. And just make it a standard users. Because we want to assign this user to a project or to a cluster later on. Yeah, then going here to the catalogs. So as in Rancher 1.0, we want to provide a really good integration of catalogs, and of course, since we are using Kubernetes, they are based on Helm charts. And basically, Helm charts. What are Helm charts? Helm charts are kind of templates for stacks of applications, and basically they make it easy to iterate over and repeatedly deploy the same application stack, but also allow you to inject custom configuration when you on deploying it. So you don't have to know, like, basically your users don't have to know how exactly the stack works, and they can then just, for example, deploy a Jenkins stack or something else consisting of several services and provide configuration at runtime to customize it. And you can also still, like in Rancher 1.0, you can create your own catalog for your own team or organization and hook it into here, and then you can use that from within the clusters. Going to the node driver. Yeah, sorry.
Jan, really quick, before you move on from Helm charts, because there are a couple questions about it. Could you, let's see, Andres asks, what is the difference between Helm charts and the library for Rancher?
The library is also basically Helm charts, but they are they're basically selected by us. They're the templates that we maintain, basically the charts. That's what the library is, right? And the Helm stable is that's the official Kubernetes library. So it's all Helm charts, but the library, because we extended Helm charts in a non-destructive way, to provide a better experience with it. So these are the ones from the library, and we can have a look at them in a moment as well.
Excellent.
Yeah.
Cool. Thank you.
So then let's start to create the actual cluster. So I think I touched it before. We try to be agnostic to the infrastructure. So you have a really high number of ways to deploy clusters out of Rancher. So let's just go through all these options here. So the first three, basically, they provision a managed Kubernetes cluster on one of these providers, and then And then we registered the cluster in this management, in the Rancher management platform, and basically start to manage it, like syncing all these role-based access control roles, also hooking into with your authentication. So this is for example something that does not work if you just create a Kubernetes cluster, a managed one in Google. They will not allow you to hook in your local user directory, like Active Directory. But the way we do it is that for these managed clusters, or basically for all clusters, we become a authentication provider from the viewpoint of the cluster, and then forward auth requests to the backend, like for example to Active Directory. And then going on, we have just the usual compute clouds. Let's just go, for example, to this one, or let's go to DigitalOcean. So let's just see what we do here. So what these node drivers do is, in this case, Rancher provisions VMs in the cloud based on the configuration that you provide. Once these VMs are running, we use our own Kubernetes installer. It's called RKE, to actually install the components for Kubernetes on these nodes. And we create a Kubernetes cluster using these nodes. And I talked about your configuration. So these are some of the cluster options that you can set. So you can choose the Kubernetes version that you want to use, what kind of overlay networking you want to use. Initially, we just have these three network providers, but we're going to add more. As long as they're open source, we're going to add more network providers here. Canal is basically a combination of the first two, where you get a layer 3 network, overlay network from Flannel, and then you get Calico for the network policies. Yeah, you can also configure a custom cloud provider. So let's say we are not using DigitalOcean. Let's say we are using OpenStack. And what is a cloud provider? Okay, so a cloud provider is another Kubernetes term. Basically, Kubernetes has plugins for specific clouds like AWS, and this allows Kubernetes then to interact with any of the infrastructure services that are available. For example, before we talked about creating a load balancer out of Kubernetes. So that's one example where it needs to know how to interact with these services in the cloud. So that's what a cloud provider is. And if we go to, let's say, if you go to custom, we should get a different option. Yeah. So these are the ones that you can configure here out of the box. And we have also a custom one, which could be something like, for example, the OpenStack cloud provider. Yeah, and in that case of OpenStack, you would configure your the API credentials for OpenStack actually here. All right, going back to the DigitalOcean one, let's have a look at node pools. So this is where you have a lot of control over the properties and the sizing of your cluster. Okay, so as you might know and should know, is a Kubernetes cluster basically like consists of three planes. You have like a data plane, which would be the etcd data store. This is where all the state and the configuration is stored. And then you have a control plane, which has the Kubernetes API server, the scheduler, and all these services that that make sure that your pods are running how they are configured. And then you have a third plane, which you can call like the compute plane or the worker plane or whatever. So this is where these are the nodes that actually run your actual workloads. So you have a lot of control over how to size your cluster. You could even do a single node cluster just for like a lab environment or something like that. Let's say we want to have a high available cluster. So, but we think that we are fine with running etcd on the same nodes as the API services. or the so-called masters in Kubernetes. So we just create a node pool called master nodes, and then the lowest number to get high availability with at most one node failing is a pool of 3 hosts. And then we assign a role to this pool, and this basically gives us a combined control and data plane with 3 nodes running in high availability. And then we can add another node pool, and we can call this worker nodes. And this is where our actual applications will be running. So this is where the pods will get deployed. And again, we can use different characteristics for the worker nodes and for the master nodes, which is often very useful. Because depending on the number of worker nodes, the resource requirements for these master nodes are actually not that high. So you can use machines with less vCPUs or memory than the machines that you want to have for your applications, for example. And yeah, and then speaking of consistent deployments, we have templates for these that define how these nodes, the properties of these nodes, basically. Yeah, I didn't save my API key. Basically, you can create a node. Let's see, maybe we have an existing node template here. Not in this one. Let's switch over to this one. Yeah, so here we have some existing node templates for EC2 and DigitalOcean. I don't know if I can edit it without a key again. Okay, let's just get an API key from here. And I'll make sure that I delete it after the demo. Okay, so let's go here, template, DigitalOcean. Okay, so now basically this is where you define the properties of the VMs that Rancher will create. You can select the region, you can select the size of the droplet, the memory and vCPU. You can choose the operating system, and you can also add labels, which can be also useful. For example, yeah, could be things like different regions that you're deploying the VMs in, or like the properties. Is this a node with a high I/O, or is this a node with a lot of CPU? So you can use these labels later on to make decisions when scheduling applications to specific nodes that need specific resources. Yeah, so these are the node templates. And going back to clusters. Yeah, once you have defined all these, added your node templates, and hit create, then Rancher will provision the VMs, install Kubernetes cluster, the Kubernetes cluster components on it, and then it will come up here in the user interface. We are using what we will be using. So let's go on what we have here. So we have also vSphere. There's also one for OpenStack. Actually, if you go to node drivers, you can enable additional node drivers for different clouds. We are using a custom one. So the custom one is basically something that you can use if you either have another mechanism to provision your VMs already, or you want to use bare metal. So this basically allows you to give Rancher existing nodes that already are running with Docker installed, and then Rancher will create Kubernetes clusters on them. And then the final option is to import. Import basically means I already have Kubernetes running, deployed in some different way, and I want to make it manageable by Rancher. So this is where you use import. So for the custom one, let's just try this out quickly. So we're just going to use the default options, hit next, and then what we get is a Docker command that we need to run on any node that we want to add to the cluster. So first off, I want to start with the control plane and the etcd. So I think I have one here. Oh, this has something running. Yeah, so this has nothing running. So let's just add this node to the cluster and run the Kubernetes control plane etcd on it. And then for the other one, we want one node to run our workloads. So we use the worker role. Yeah. That should be resolved in a minute. So now I would expect these nodes to register. And yeah, okay, 2 nodes have already registered, and that's all we're going to do for that cluster. So they're done. So now you can see that it's provisioning this cluster. It's going to pull all the images for the Kubernetes components from our Kubernetes distribution and run them, create the overlay network between the nodes so that you have a networking between them, and install some other components. So this can take a couple of minutes. Yeah, maybe this is a good moment to have some questions.
Sure. Actually, we have been doing a great job of answering them. There's been a lot of questions around Helm and secrets. So Vikas asks, to do a Helm deployment with Jenkins, what do I need to do on the Jenkins side and the Rancher side? He asks a version 1.6 question. So I'm not sure if you can also address this from 2.0.
So the way, okay, I mean, I'm not exactly sure what he wants to achieve, but I guess that maybe he wants to run a work or something from a catalog, or basically trigger a catalog or a Helm chart deployment from Jenkins, I guess. So if he's already doing that in 1. I don't think it will be very hard to do it in 2.0. Basically, you can use you can either use a REST API call in your Jenkins build step, or you can even use the Rancher CLI tool to deploy from a catalog. So I will come back. I will come to that in a moment.
Okay, great.
Any other questions?
Let's see. Most of them have been answered privately, but this one might be good for everyone. This is from Mick, and he asks, do you have any recommendations for secrets management with Helm charts? Quite often, the values.yaml will require things like AWS keys, making it difficult to manage these files in source control.
Yeah, basically you can reference secrets that you have in the Kubernetes secrets store, and then they will get pulled once you deploy the catalog. So that's how you could do it.
Okay,
so
cool.
you put your secrets in the Kubernetes secret store, and then you use the name of the secrets in your catalog template, or even use it as a template var when you deploy the Helm chart.
Awesome. There were also a couple questions around importing clusters. I know you went over that a little bit. Do you want to speak any more to that?
Was there some specific questions, or?
No, just how do you do it?
Okay, so basically the way we work with these clusters that we manage is that we have something called a service called Cluster Manager, and it has a counterpart like an agent running in the cluster that we manage. So the Cluster Manager is running in the Rancher management cluster, so to say, and then in each of these clusters that we're running, we have a counterpart agent, basically that bridges these external clusters to Rancher to enable us to manage them. And for the import, basically the way it works, you provide access to the Kubernetes API, basically management access to the Kubernetes API of the cluster that you want to import. And then once it's imported, it will work like any other cluster out of Rancher. So you can use all the user auth, all the other stuff that you can do with other clusters. Yep. Okay, so let's see. So our cluster is ready. I don't know why I probably didn't give it a name when I deployed it. but that doesn't hurt us. So this is like the dashboard view of the cluster once it's deployed. So you get like a quick view over the resources that are available, like CPU. So this is the whole, like we have 8 gigs available in the whole cluster. And this is the number of pods that we can still deploy. There's a limit of around 100 pods per node in Kubernetes. It's just set as a hard limit. So that's why you have 220, since we have two nodes. You get also some health checkboxes here. And then if you look at the nodes, we also have like, we can manage the nodes. We can see like the roles that they have. We can edit them. We can edit the labels of the nodes and stuff like that. Yeah, or we can even go to the node level to see the resources there. And we also get, we also get like these Kubernetes stats that it collects, in the UI. So then, so now we are basically on the cluster level. We have seen the nodes, we have storage, project namespace tool. So now we have to talk about projects. What are projects? Because in Kubernetes, you don't have projects, you just have namespaces. So basically, project is something that we came up in order to make it really nice and easy to share a cluster with across different teams while having isolation between them. So the way we do that is actually we leverage the namespacing capability, but we manage all that stuff behind the scenes, basically putting namespaces in groups, setting up network control so that they are isolated on the network level, setting up the access control so that only members of a specific project can access the namespace of it. So by default, you get a default namespace. So it's the one that we see here. That's the first namespace that you always get in a cluster. And then going on from there, you can create more namespaces. So more projects, sorry. So there are a lot of use cases for that. So as I said before, you can use one cluster and then give access to different teams without them interfering with each other's workloads. Or you can use one cluster and have like different projects for staging or for QA and stuff like that. Or even like for like continuous integration, you can use one cluster, and then for a lot of pipelines, you can for different pipelines you can use different projects, and you have all that separation between the projects. So the way we are doing is we are under the hood, we are leveraging namespaces, and that way we don't break anything with like traditional workflows with Kubernetes. So we can still use kubectl and stuff like that. So let's go to the default namespace. Let's go back to the cluster. We have some stuff here that we talk about. So we have the project namespaces. Here, basically, we set up the members of the cluster, right? So we have a cluster owner by default. And the cluster owner, he basically manages stuff like the nodes, like the properties of the cluster, like the physical properties, how many nodes. He can add new nodes, he can manage the nodes, he can create new projects, and he can add members to projects. And then one thing here important is the alerting and notifying. So this is new in Rancher 2.0. Basically, we want to make it easy out of the box to get you running with monitoring. So if you go here to logging, for example, if you have like an external log aggregator, it's very easy to set it up. You basically just give it the target, or let's say syslog target or Splunk target, and then we send all the logs from the cluster level to that external aggregator. And that means we are not going to send the application logs, but just basically the stuff that like a sysadmin would be interested in. Like is the etcd, what is the etcd doing? What are the Kubernetes APIs doing? Stuff like that. And similar to that, we also have alerting. based on the state and the resource usage of the Kubernetes components. Again, this is not the applications. This is just the Kubernetes plane, like etcd, scheduler, API, and so on. And you can create your own alerts here. You can select which service you want to monitor, stuff like that. And you can also set up notifiers that get triggered with an alert. So you can send a Slack message, email, PagerDuty webhook. And yeah, that's alerting, notifying, logging. And then we also have pipeline. This is configured at the cluster level. So basically, you connect it to a GitHub account or GitHub organization, which I haven't done here, but I think we can switch over to this one here. Yeah, so here I've already connected it to my GitHub account. And you do this at the cluster level, and then the actual usage of that feature, like the pipeline feature, is happening in the projects themselves. Okay, so this is the cluster level. So now let's go to our default project. And this is what your users, DevOps, will see when they're managing their actual workloads, when they're logging in. Since we were just talking about alerting and logging, so now basically you get the same configuration here for alerts and for logging, but this time we are talking about the application logs and not about the Kubernetes management logs. You get the same features for logging and for alerting, and for alerting the same thing here. We are not trying to alert on Kubernetes components. We want to have alerts for our applications. So we can set up custom alerts for a specific application. For example, when the CPU usage goes over a specific threshold that we set before, we want to have an alert. Yeah. Under the hood, we are actually running Prometheus to implement the monitoring. And next off, you can also configure certificates. So this is primarily for Ingress or load balancers. Basically, yeah, the certificates for your web endpoints. And then also the config maps, we talked about this before. So config maps could include something like an external API endpoint for our application. Or for example, different configurations for staging and production, stuff like that. So it's a key value thing, and within the map. So you have a config map you could scope it by application name, for example. And then you can define several key value pairs for that this application might need for its configuration. And yeah, the logging, we already had this. And similar to the secrets, they also are a map. So you can have secrets for your app, and then you can define like API key value, and you can define if it's only available in a specific namespace or to all namespaces in this project. So again, the secrets and the configuration is also scoped by project. So that really means that if you have multiple projects with different teams accessing it on the same cluster, each team will only have access to its own secrets and to its own configuration values. And let's see what else we can do here. Registries. So this is for custom registries. If you have a local Docker registry, you can add the credentials here. And yeah, so next off is creating a simple workload. Maybe we do a pause here for some questions. Matthew?
Yeah, let's see. Starting with Dave, he's been waiting a while. He asks, is NFS available in 2.0?
Yeah, it's yeah, I would say it's available. There are a lot of, I mean, it depends if he wants to talk to an external NFS server, or he wants to have like a hyperconverged NFS in the cluster. But I will give an example in a minute. Yeah.
Okay, great.
Of how to basically, we're going to talk about how to provide persistent storage here.
Okay, great. Yeah, there's a couple questions about storage and persistent volumes. Let's see.
I can just continue. If
Yeah,
you
just
see
continue.
anything.
Yeah, there's
Okay.
pipeline. You're going to get into that as well.
Okay. So yeah. So let's just deploy a very simple application, basically, just to show you how the UI is working. In case you're wondering, so similar to Rancher 1. This nice GUI that you're seeing is basically just an API client. So everything is, the whole GUI is client side, and it talks to the Rancher REST API. That means that all the actions and the functionalities that you can do in the UI, you can easily replicate them in any other API client by calling our REST API, which makes it great for integration in existing systems or automation. And similarly, we have another API client, which is our CLI. And I'm going to show this also quickly in a minute. Okay, so let's just start deploying a workload. Let's see, I had this image here. Let's use this image. Okay, so give it a name. Just choose the Docker image that you want to run. You want to deploy it in the namespace, in the default namespace. Now the workload type. Let's see what options we have here. So the default is a deployment, and we talked about the deployment before. And we can also set the scale of the pods. So let's say you want to run 2 pods of the service. The other options are run 1 pod on each node. So this is basically a global service that automatically runs on each node. So even if you add nodes to the cluster, this application will automatically also run on these nodes. And then we also have stateful sets, which are kind of an iteration over deployments. They have a little bit different properties with regards to volumes and networking and names. Yeah, you can learn about them later. And then we also have cron jobs and run on a cron job, and then we have actual cron jobs. So these have a little bit different names than the actual Kubernetes semantics. So this would be a daemon set in the Kubernetes semantics. Okay, let's just use the scalable deployment, and then this is similar to Rancher 1. You can add environment variables, and you can control all the properties of a pod. So this is basically what you would, if you were to use a Kubernetes configuration file. All the stuff that you can do in this file, you can also provide it in the UI here. And yeah, so this is also a nice thing. This is also a nice property of a deployment. You have a lot of control over how it should perform a rolling upgrade. Yeah, basically like draining and stuff like that, and how quickly it should perform the upgrade and what the batch size is. Yeah, then port mapping. So we know that this container is running on port 80, and we will run it as a node port. And if you're using node port, then most of the time you will not bother to select a port, and you will just have Kubernetes create a random, basically reserve a random listening port. Yeah, so let's just do this, and let's just launch it. Okay, so let's click on the deployment, and we can see that there are 2 pods that have been deployed. So that's exactly what we wanted. And then similar to Rancher 1. You can access these pods / containers directly. So you can use logs. So this container obviously does not log anything to standard R, but you can use a shell. Yeah, so this is pretty similar to what you have known in Rancher 1. And then if you go back to workloads, it gives us the random port that Kubernetes has assigned to this application, and we should be able to access it. And since we have deployed 2 pods, I would say if you refresh this, we should get a different answer now than now then. Yeah, I probably have to repeat this a number of times. Okay, I think it wants to do sticky session or something. Anyways, so this is the random port, and now you're probably wondering, how is that useful? Should I mean, if I have my web application, should I give my users this strange port number? Yeah, no, of course not. So there's a different way to get traffic into this application, and this is called an ingress controller. And here in the UI, it's what we call a load balancer. An ingress controller, basically, the load balancer that we have here in Rancher is basically an Nginx reverse proxy. And the difference to the node port is, first of all, it's running on port 80 and 443. Secondly, it allows you to set up SSL for your application using the certificates that you have provided. And thirdly, it allows you to define layer 7 rules for your access. So that way you can actually use this load balancing functionality for different applications, and then based on the host name and path, you can forward it to the right pod. So let's delete this application for now, this deployment. And create a new one. Call it load balancers. So this time we don't have to do any port mapping here, because we don't want to use a node port, we want to use a load balancer instead. And let's use a scale of 5. And I think one thing that we also did, let's see if we selected that actually. Oh no, we did not do that. Okay. Actually, I have a old ingress here I want to delete. So add an ingress. So let's call this global LB. And now we can automatically generate I don't know how to pronounce it, xip.io host name. So this is basically a fake DNS name that actually still works in the public DNS, but costs you nothing. Alternatively, you can, of course, set up integrations with your DNS provider like Route 53 or what have you, and then automatically create DNS names for your applications. So we're going to do that. And now you can see we have these basically, as with any other layer 7 load balancer, we can define the rules. In this case, since it creates a host name for us, it will automatically add a rule for that host name as well. So we choose the workload, hello world, the port that our deployment is listening on, and then we can set up SSL certificates if we wanted to do that, and provide labels. Okay, just create this one. So now this is it's going to provision this. It's gonna provisioning a DNS name. It's gonna take a little bit. I think it's already done it. So now we are able to use this DNS name, and we are able to use port 80 or 443 for SSL to access the application. Yeah, going on service discovery. So service discovery in Kubernetes basically is using DNS A records. So this is similar to the service discovery that we already provided in Rancher 1. It's just using DNS names basically. And whenever you deploy an application, it gets assigned a DNS name, and within the same namespace, any other. So why do you want to do that? Of course, this is if you have a stack of several applications that need to talk to each other, or even have like a microservice architecture. So in this case, you want to use these DNS names to talk to the other services. And yeah, so every workload by default gets this namespace. You can also add custom records or records pointing to external applications, and then those are resolvable in the DNS namespace then. So these are service discovery, and let's talk about volumes quickly. So let's see. Okay, so we have to go to the cluster level storage. Yeah, so basically you have there are two ways in Kubernetes how you can provide a persistent storage or persistent volume. You can either create it beforehand, define it beforehand, or you can use something called a storage class, which is basically a dynamic provisioner of volumes that are backed by some kind of persistent storage. Often this would be a storage class that would interact with an infrastructure storage in the environment that you are in. For example, on AWS, Elastic Block Storage, or Cinder in OpenStack. So it would basically interact with some kind of external storage. And what happens is when your application requests a volume, basically this storage class or this storage provider, it will provision a volume, or which could be, for example, a block device on this external storage, and then make sure that if in the case of a block device, that the block device is attached to the node where the application will be running. Or in case like of a shared medium like NFS, it would mount the NFS export to all the nodes, so that even when you're running several pods that need to access the same volume, they can do that as well. So one example to just demo this quickly is to use the NFS provisioner that is in the catalog. If you go to catalog apps, oh, it's actually already one running. Let's delete this one. So what this NFS provisioner does, it does not use an external NFS. It actually runs its own NFS server, and then uses the available disks on your nodes as its storage. Yeah. Let's see. NFS provisioner. I hope my internet is not gone.
Well, I can see pretty well.
Yeah.
Well, you're still sharing at least.
Let's switch to this one then. Oh, it's still there. Okay. Catalog apps, launch. Okay. All right. So yeah, as I said before, basically this runs an NFS server in your cluster itself, and then creates volumes on that NFS export. I think, let's see, what do we have here? Oh yeah, we have to use the other path again. So this is basically the host path that it will use on these hosts to create the export or to store the data in. This can be any like directory that exists, right? Yeah, that's anything. So when we launch this, it should actually run a pod on each of the nodes. So I think I have 4 nodes in here. So it should run on all of them. Yeah, okay. And then what it also should do is it will actually, this service which will register itself in the API as a provisioner. So that's what we see here. And then once this is active, we can start either explicitly creating new volumes, or like launching applications or deployments that set a volume claim. And a volume claim is basically what connects a pod or an application to a specific volume. Yeah, as I said, we can do it explicitly. We can just create a test volume, then use the NFS provisioner as our storage class, and give it the capacity. And we can also customize it for single many for the different access modes. And then when we hit create, we can see it's bound. That means that there's a persistent volume claim for that volume, which is this one, and it is provisioned on the NFS. So now, when I create a new workload, we can actually then mount that volume to our workload, or we could request a new one. Let's just use a claim for a new one to see how it works dynamically. Again, we use the NFS provisioner. We want a volume of 1 gigabytes. And let's just launch it. Oh, 13 API containers. Forget anything here? Probably not seeing what I did. Oh, all right, okay. I forgot to add the mount point. So this is where the volume will be mounted in the container. Okay, so you can see that the application is starting up. And we can see that there's a new test dynam volume that has been created. And yeah, something is not right with that mount. I've seen that before. So it's actually a good moment to show you the CLI capabilities as well, because we can troubleshoot what happened here. Let's just switch to our CLI. So let's go to the kubectl. How do you use the kubectl? Quickly show you. You go to the cluster level, and then you get a kubeconfig file here with your token. And then when you download kubectl, which is the Kubernetes API client, you set it up with this configuration file. And when we do like kubectl config view, we can see that it's set up for me correctly. And then we can get the pod running, and we should be able to see what's going on. So you can see that this mount is still stuck in container creating. And we can maybe get an idea why that is happening. Not inspect. It's probably something, oh, it doesn't have. Let's see. Oh, okay, sorry. Forget something here. Okay, so now we get basically the state of the pod. And we can see that there's an issue with mounting the NFS volume. So it seems to be that there's some kind of issue with this NFS provisioner. I mean, it's not really something that should be used in production, but it should work in the demo. So I'm disappointed, but yeah. So have to pray for the demo gods better next time. But yeah, so we would have expected it to basically give us to mount this NFS export in the container, and then we would be able to write our data in there. But since we are on the command line, we can actually see how we can do all that stuff from command line as well. So the API client for Kubernetes is called kubectl, and that's actually what you use with Kubernetes to create new resources, to perform updates. So basically, it's an alternative to using the Rancher UI. You can use the kubectl. Or if you want to do like automation and you don't have an actual API client, but you just want to maybe wrap kubectl commands in a bash script, then that's also something you could do. So let's have a look. I have two files here. So this is basically my application that I want to deploy. I have a deployment, which is a deployment resource, and I have a service for my networking. And we can just have a quick look at it. So this is how my deployment looks. It's one container. The important stuff here is, first of all, the namespace. So this is the namespace that I want this application to be deployed in. And the other important thing are my labels. By labeling my resources, I can target them in other resources, basically. This is my reference. This is my way of referencing resources between each other. And then this is basically everything that you would also have in the Docker Compose file nowadays. So this describes the containers as such. So the name of the container, the image it should use, and the ports, and this describes the ports that the container provides services on. So I have port 80 and port TCP. And then just by running this deployment, I will not have a way to access it, right? So I need to create a service as well. And now we can see why this label was important, because I'm creating a node port type service that will be listening again on a random port, but I'm targeting basically this backend port 80. And the way that this node port service knows where it should forward the traffic to is because I gave it a selector. And in the selector, I have a key value pair of a label name and the value. And this is what corresponds to my values that I put here. So how do I get this file into my cluster? So I have already set up my kubectl before, as I showed you. So we can see what's running there with regards to pods. So I have just my Hello World LB application, which we can maybe just remove that both to make it more cleaner here. Yeah. So now we want to, we can also look at deployments that we might have now. Okay, so this is still being cleaned up. All right, so now let's create the deployment. The way we do this is we use the apply command and we use the name of the file that we created. And it says hello world created. And actually, when we switch back to the API, we actually can see that the API reflects that as well. And we can also get pods again. And we can see that we have one pod. And this actually reflects the scale that we have set here. Are there any questions, Matthew?
Yeah, sorry, I was on mute. Let's see. So going back to the NFS server, Simon asks, when you mention the NFS servers being created on each server, is that just replicated between all the nodes so that if a node is offline, the same data is still accessible? Is that how it works?
Sorry, I just had to cough. No, I think it's actually just one NFS server. but when, let's say, when a pod is when a pod is wanting to use the volume that is backed by this NFS server, and the pod is scheduled to a different node, then it will just use basically the overlay network to mount that NFS volume using the overlay network. So then it will not be local storage, but like basically very close storage. But it's just one NFS server that is running.
Cool. Okay, thank you. Okay, so the next one, Jeremy, this is from someone named Jeremy, who's been waiting patiently on this question and asked a while ago. He says, I'm interested in hearing more about setting up CI, continuous integration, and how to organize them with projects. So I know you did namespaces, I think. Could you talk a little bit about the projects?
Yeah, I'm happy to answer a specific question. I mean, I can kind of think what he might want to refer to, but setting up CI or CI/CD as a whole we're going to provide a specific training for that. So if there is like a more specific question, I could certainly answer that.
Okay, cool. Let's see. William asks, is Portworx supported in the catalog?
I don't think it is in the catalog. And the reason, I don't know. So I don't think it's in the catalog. But yeah, it's not in the catalog. So the catalog is still growing, but it might be. Oh, it's not. It's also not in the Kubernetes catalog. So you can just you could create your own catalog, put it in there, or just deploy it from manifest files. But there's no reason that it shouldn't work. Yeah. But we're gonna add more stuff in the catalog. Our own catalog is still growing. It's still very small compared to the Rancher 1. catalog, which has I think over 100 templates. So our own catalog is still growing, and we're going to add more stuff specifically for persistent storage. So one of the things that we are going to add is in the catalog is Rook, which other than Portworx is open source. So that's one of these things that we're going to add in first. And basically Rook provides hyperconverged storage using Ceph, but with local storage of the nodes. So that's something we're going to add. And it's also something that you maybe, like any of you who's interested in getting persistent storage to work, might be worth looking into as well.
Cool. Awesome. Okay, going on. Naveen asks, can I set resource quotas for projects using the Rancher GUI?
I haven't actually tried to do that in the UI myself. I think it's here stuck here. I think my internet is really bad today. Let's just reload it. Let's go to advanced options. I think it just might not be exposed in the UI at this moment. So I don't know if that is in the works. Oh no, it is actually. So we just have to go under labels and annotation, which totally makes sense. Oh no, security and host config. Okay. So yeah, so this is similar to the UI in 1. You can configure resource reservations in the UI as well. Yeah.
Awesome. Okay, going on. Vicus asks, in my current cluster, I can reach the Rancher master web portal with HTTP and HTTPS, but I want to reach just with HTTPS. How can I disable HTTP port over Rancher? I tried it with Firewall, but it doesn't work. Is it a bug?
So I'm guessing he's running the container. I I'm not sure. I think there's a way to disable port 80 actually without the firewall even. So, but on the other hand, I think that port 80 is actually just a redirect really to HTTPS. So you cannot really. Let's just try it out. I think it just redirects to SSL actually. So it's not really giving you a plain. Yeah, it's just a redirect. But there's a way to disable it. It's in the documentation. So I think if you go to installation and then I think somewhere here with the load balancer, there's an option. Yeah. Oh, okay, so this is specifically for an external load balancer. If you pass in the header. Yeah, okay, but anyways, it's just a redirect, so it doesn't give you plain HTTP access to the UI. Yeah.
Okay. Let's see. William asked, and a couple other people have asked this too, if there is a path of migration from 1.x Rancher to 2.x. If you want to talk a little bit about the upgrade process.
So that depends a little bit of what kind of environment you had in 1.0. So if you had already a Kubernetes environment, you can import it to Rancher. But if you had, if you were using the Cattle Docker Compose based environment, then there's no direct migration path. But I think, I'm not sure, but I think we are working on a tool to convert your Docker Compose files. I don't want to like promise anything, but that's what I heard last time I was checking. But
Yeah, I'll echo that. I heard that as well. That it's a tool coming out in 2.1.
yeah, but there is no direct path between basically the management, the deployment. So you cannot upgrade from 1.0 to 2.0. It's a new deployment, but you can migrate your workloads between those two.
Okay, cool. Going on, Naveen asks, is there any source to image deployment concepts with Rancher, like trigger builds from Git using webhooks?
Oh yeah, that's a good point actually, because we didn't cover that really yet. Yeah, so this is pipelines. This is kind of what we're gonna build, what we started to build to provide this kind of source to image concept or source to application. Basically, this is for people that don't yet have like an existing pipeline built out with Jenkins or something, or they don't want to do that for a little project or something. So you can set up pipelines directly here in a project. And the way it works is basically you point it to your GitHub repository for which you want to set up CI, and then choose the branch that you want to trigger pushes. That you want to trigger pushes from. And you can also set up triggers for PRs or just for commits or for tags. So tags would be useful for like a release. PR is basically to check PRs if they pass testing and stuff like that. So so this is a way to really quickly set up a pipeline in Rancher. So we have set up the environment. So next we want to add our build steps. So we can use different languages to do that. So this basically then we're using this basically to execute any kind of unit tests. And then we could have another step to do infrastructure tests or anything like that. And then as a last step, you would have a publish an image step where you push basically that release or that commit. You build an image and push it to either your own or to the public Docker registry. And going on, we will add actually another step, another type of step, which would be deploy. So then you can build a CI/CD pipeline to actually deploy the image in the cluster as well as a pod, as a deployment. Yep.
Okay, awesome. I think that's it. That's all. There aren't any other questions that have been asked.
I'm just gonna show pretty quickly because I mentioned it before. I mentioned before that we have a CLI client as well, which is basically an alternative to using the UI and provides most of the functionality of the UI. So this is really something more for the cluster admins or for the sysops, where you can manage your clusters, manage projects, manage the settings, create new clusters, add new nodes, stuff like that. So let's see, nodes. Yeah, so this is basically the CLI equivalent to the UI. It's just called Rancher CLI. You can download it from GitHub. And to set it up, I just want to show that really quick. Is I think it's Rancher login or something. Yeah, basically you give it the URL of your server, and then you have to create an API token in your project or in your cluster. So you go to the user menu, API and keys, create a new key for the CLI, and then you have to use the bearer token. You copy this token, and let me just you copy this token and you provide it as the token, as the value for the token argument, and that way you can use the Rancher CLI. Yep.
Awesome. Anything else you wanted to show, Jan, or should we wrap up?
No, I think we're good. I think
fantastic.
That's everything I wanted to cover.
Excellent. Okay, great. This is awesome. Usually we are just like struggling to get it all in by the end. So let me see if I can take back control of the presentation.
Okay.
Does that work for you?
Sure.
Okay. All right, so just a couple more things, some housekeeping before we go. The slack.rancher.io, continued conversation and community around these topics. Also forum.rancher.com. You'll also find help there. Other than that, thank you all so much. You can read more about our Kubernetes work on rancher.com/Kubernetes. And that's it. Again, you'll get a recording and the slides and email in the next 24 hours. So other than that, everybody have a great day. Talk to you all soon. Thanks, Jan.
Yeah, thanks everyone for joining. See you around.
All right, bye everybody.